Well, I got you here for an update, for a Capstan update. I always love my Capstan updates. You've been very, very active, haven't you?
Yeah, no, it's been a fun, man, we haven't talked in a little while,
It's
huh?
been a bit.
Yeah,
It's been a
so
bit.
we're out, treating patients right now, which
I
is
know,
super
and so
exciting.
fill me in. What can you share? And
Yeah.
I know you got to walk a careful line here
Yeah.
for all kinds of reasons.
Absolutely. So our target has been to go through a 10-ish patient first in human in 2025, and we're on target to finish that by the end of this year. So
Both the system and the valve.
yes, so we're bringing to these sites, we're bringing our full robotic platform, our catheters, and our mitral implants. Yeah.
And as much as you can share, you're still smiling, as much as you can share, what have been some of the observations by the clinicians on this?
Yeah, so we've been at 2 different sites with 3 different operators so far. And one of the best things I like about it is that they're just loving how calm these procedures are. These are first in world robotic mitral replacements, right? And we are just moving smoothly through the procedures. The patients are incredibly stable. I think we've talked about one of the key premises of our designs is that our implant can be partially opened and has active leaflets. So you can be sitting, fine-tuning the position, but you're hemodynamically stable. And so you can optimize that position for that implant all before you release it in a stable patient. And so they're, I think one of the clinicians said they are beautifully boring. And so we really like the procedures to be beautifully boring. So
And it shouldn't be lost, and our viewers will know this. I mean, that's a complex procedure, generally
Yeah.
speaking. When you think about any of the 30 plus valves that have been out in the market right now, it requires a skill level that is well beyond the norm.
yeah, but the nice thing is all of a sudden we now have a computer in the loop, right? So what we're doing is we're taking all of that preoperative imaging that you need to size the implant already, and we're doing patient-specific pathway planning. So our system is helping the clinician. It's assisting the clinician in navigating through those complex, moves, those turns. And so there is a way that they can, they're crossing the septum, they're in cross the septum mode, and there is a patient-specific coordinated motion to cross the septum. They can fine tune it, they can do whatever they want with it, but it gets them kind of 80% of the way there. And so that really, just simplifies. There's not the cognitive load of needing to, I'm gonna turn this knob now to do this thing, and then I have to compensate over here. A lot of that, the system is assisting with that complexity. Yeah.
And that cognitive savior then can be deployed at decision making at a very, very important time.
Yeah. Well, it's not even coming in there to make the decisions. It's actually to get the technology out of the way from the clinical decisions. Anatomically, I want this device to be in this location. Mm-hmm. We're just simplifying the movements of the technology to get there.
Yeah.
And so they're just focusing on the clinical intervention, and we're taking out the complexity of the device.
Right, and that I should have articulated that better. Is the decisions aren't being made by the computer, so to speak, mm-hmm. but you're saving all that cognitive calories at the right time for the clinical decisions that need to be made.
Well, and the great example of this, in a lot of these devices, especially when you're going from the right side of the heart to the left side of the heart, it's about getting to the tip to the position, but it's also about getting the rest of the device optimized to let you do what you want to do. Mm-hmm. Now, a clinician wants to just think about what is right in the valve, but we can think about how you set up, for lack of better terms, the shoulder and the elbow to optimize where the tip of the device is. And so that's where you don't have to think about, you usually when you're writing, you're just thinking about where the tip of your pen is going. You're not thinking about how your elbow is clearing the table. Right. We're doing that for.
Well, this is where your intuitive legacy comes in, right? The shoulder and the elbow and the other.
Sorry, I can't help myself.
Well, thankful for it nonetheless, right?
Yeah.
So we're starting in mitral.
Yes.
But clearly, as we've watched structural heart go, we always leak over into other potential structural opportunities. Are you thinking anything around that?
Yeah. So we very quickly realized it was 2022 when we had said, hey, we know what this implant needs to do. We know what this catheter needs to do. a robot is going to be the right deployment method, right? And so we pivoted into our robotic program back in 2022. And we had a proof of concept up and running in 6 months.
Wow.
And almost immediately, we realized this didn't just have to be a mitral device. This was going to be a platform that can really navigate all the complexity in the structural heart space. So our team very quickly kicked off a tricuspid replacement program that we have in preclinicals. Our mitral is our focus. Like we believe that that is one of the greatest, underserved patient populations, and we think this technology can really help that. And so we are 100% focused on mitral, but these are also long, timeline development programs. So our tricuspid is in preclinicals, and we're looking to get that into patients by the end of next year.
Yeah, and it makes sense because I think the last time you and I chatted, I don't think we were on camera when we were doing it, we were at SRS together in Strasbourg. And this sets up as a very formidable surgical platform, surgical robotic platform that allows you to apply forces and do things in the heart that if not but for, you can't do pushing and pulling on a catheter by itself.
We want to operate at the intersection of cardiac surgery and cardiology.
Yeah.
Like we want to bring that stability and precision and capability. So we're going to start with a portfolio of implants, but you can imagine there can be instrumentation that can help in leaflet modification or other types of interventions that we want to have that same stability and control in that area. So I view this as it can be a platform that can broadly serve structural heart, and I can imagine that there's going to be concepts for implants or interventions that can come from understanding that there's a platform there that can do those sorts of things.
That's right, because until Capstan, we were working with a single modality of delivering an intention via a catheter for the most part, if we go to the interventional side of things. So now I think we'll see different solutions, end effectors and devices, energy delivery, ultrasound, et cetera, that can come based off that platform.
Yeah, absolutely.
So what should we be watching for the next 12 months before TCT's in San Diego?
I was excited to hear is in San Diego.
Just today
yes.
that we were.
So I think the next year is going to be really busy for us. So we're in multiple rounds of conversations with FDA. We're targeting to get our EFS submission here in probably around the Q1 and a Q1 timeframe. So we're hoping to be enrolling patients by the end of Q2. With that, there's all those awesome field support teams. Like we're bringing robots into the cath lab, right? Which is kind of a fun, like place to be in, right? I can't tell you how fun it has been to work with these clinical teams, these nurses and care professionals that aren't used to seeing a piece of technology like this. We've even got a simulator that everybody can take and drive, and we're just having such an amazing time working with those care teams. And so we're going to be building out our own internal staff to a field support team and whatnot to support the EFS, both in the US and will be international as well, in preparation for ramping up to the pivotal.
So for those that are interested and want to probably have the time of their life in their careers for the next few years.
Come talk to us.
So clinical people, field support people.
We got imaging proctors. We're going to have device proctors. We've got, don't get me wrong, we got plenty of engineering roles in-house, as we scale our implant, catheter, and robotic teams. So all of that will be scaling quickly and continuously for the coming year. Yeah.
Fabulous. And I can tell you from the work we've done with you, the teammates have joined you are ecstatic. So let me just give that as a validation, as if you need it. So. Well, as always, I appreciate your time and sharing the journey with Capstan and where we're going.
Awesome. It's great to be here, Joe.
Thanks.
Yeah.
I'm Joe Mullings from the floor of TCT 2025 in San Francisco. Be well.